we are going to have a look at what odd numbers are. If you are asked to list the first 5 odd numbers, that would be 1, 3, 5, 7, and 9. So all odd numbers are numbers that are not divisible by 2. So 2 will not fit into any of these numbers perfectly. Odd numbers start with 1, and it's every second number thereafter. If in a number sequence we get something that looks like this, we need to try and pick up that 11 and then a number we're not sure of, that's what we need to figure out, then 15 and 17, and then another number that we're not sure of. We need to try and pick up that the difference between the two numbers that we have, the two consecutive numbers that we have been given, is 2, and those are both odd numbers. So if we were to plug in a number here, 11, 12, 13, we need to see then if the pattern will be consistent. So 11, the difference between 11 and 13 is 2, the difference between 13 and 15 is 2, the difference between 15 and 17 is 2, and then we obviously need to have a difference of 2 here as well, and that will obviously be 19. We are now going to have a look at even numbers. So the first 5 even numbers are 2, 4, 6, 8, and 10. So an even number now is divisible by 2. They start from 2, and it's every second number thereafter. So it's basically just the 2 times table. Every number that appears in the 2 times table will be even. So all multiples of 2 are even. Right, so if in a number sequence we get something that looks like this. We need to try and pick up that the 2 consecutive numbers we have been given, there's a difference of 2. So we just play around a bit and we say 20. If this were to be 22, the difference would be 2. Then the difference between these two numbers, if that was also to be 2, that would be 24. So the difference between 24 and 26 is 2, so that works out perfectly. So we can see that this number sequence is listing even numbers from 20 to 28. Right, so if we have a look at prime numbers, a prime number is a number that has only 2 factors. So we need to determine what the first 5 prime numbers are. So if we look at the number 1, 1 only has 1 factor. So it is therefore not a prime number because prime numbers have to have 2 factors. So we then have a look. The number 2, is 2 a prime number? It is, because the number 2 has factors of 1 and 2. So it has exactly 2 factors. The number 3 has factors of 1 and 3. So the number 3 is a prime number. The number 4 has factors 1, 2, and 4, so is therefore not a prime number, so we cannot list it as one of our first 5 prime numbers. The number 5 has factors of 1 and 5, so 5 is a prime number. The number 6 has more than 2 factors, so it's not a prime number. 7 has only 2 factors, 1 and itself. 8, 9, and 10 all have more than 2 factors, so they are not prime numbers. The next prime number is 11. So our first 5 prime numbers are 2, 3, 5, 7, and 11. Now, if we get a number sequence that looks something like this, we need to try and pick up that this is a number sequence that is listing the prime numbers between 7 and 19. 7 we know is a prime number, so when a number sequence starts with 7 and you can see clearly that there's no other obvious pattern and they're not listing the multiples of 7, then it's highly likely that it'll have something to do with prime numbers. So if we plug in the next prime number here, that would be 11. 7, then 11. 12 is not a prime number, so that works out well. The next prime number is 13. 14, 15, and 16 are all composite numbers, so that works out well. 17 will be your next prime number, and therefore 19 will be our last number there that we needed to fill in, because 18 is also a composite number. It has more than 2 factors. As you can see here, 1 and 2 would be the only factors, 1 and itself would be the only 2 factors of any prime number. So the number 17 has factors 1 and 17. No other number fits perfectly into 17, so that makes it a prime number. So the number 53 is a prime number because only 1 and 53 fit perfectly into 53. We are now going to have a look at composite numbers. Composite numbers have more than 2 factors. So if we have a look at our first 5 composite numbers, we know that 4 is our first composite number because it is the first number that has more than 2 factors. The number 4 has exactly 3 factors, 1, 2, and 4. The next composite number is 6, then 8, 9, and 10, because all of these numbers have more than 2 factors and they are therefore composite numbers. So if we see 9, 10, space, space, and 15 in a number sequence, we could be tempted to say, well, 9 and 10 are consecutive, so we could put 11 and 12 there, but then we've got 15, so that one wouldn't work. We would need to try some other options. We need to recognize that 9 and 10 are composite numbers because they have more than 2 factors. And because 9 and 10 are composite numbers, we need to see if 15 agrees with that. So does 15 have more than 3 factors, more than 2 factors? Yes, it does. It's got 1, 3, 5, and 15. So 15 is also a composite number. So let's see whether there are only 2 composite numbers in between 10 and 15. So 10, 11 is not a composite number, 12 is a composite number, 13 is not a composite number, 14 is a composite number, and our next composite number is 15, so that works out well. We are going to have a look at factors and highest common factors. HCF stands for highest common factor. So factors are all the numbers that fit into another number. So the factors of 18 would be 1, 2, 3, 4 doesn't fit into 18, 5 doesn't fit into 18, 6 fits into 18, and then we've got 9 and 18. So the number 18 has 1, 2, 3, 4, 5, 6 factors. If we are to look at the HCF, or the highest common factor of 12 and 20, we have a look at the smaller number, which is 12, and we list the factors of 12, which are 1, 2, 3, 4, 6, and 12. We then go to the highest factor of 12, and we see, does 12 fit into 20? No, it doesn't perfectly. Does 6 fit into 20? No, it doesn't perfectly. Our next highest factor is 4. Does 4 fit into 20? Yes, it does. So 4 is the highest common factor of 12 and 20. We are going to have a look at multiples and lowest common multiples. LCM stands for lowest common multiple. Let's have a look. If we wanted to list the multiples of 8, that is basically just the 8 timetable. So it's all the numbers that 8 goes into perfectly. 8 will be a factor of all the multiples of 8. So our first 5 multiples of 8 are 8, 16, 24, 32, and 40. So as you can see, 8 fits perfectly into all these numbers, and therefore 8 is a factor of all those numbers. 8 is a factor of all the multiples of 8. If we want to have a look at the LCM, let's use the same example as before, of 12 and 20. We now need to have a look at the bigger number, and we start listing the multiples of 20. 20, we see if 20 is a multiple of 12, does 12 fit into 20 perfectly? No, it doesn't. So we go to our next multiple of 20, which is 40. Does 12 fit into 40 perfectly? Is 40 a multiple of 12? No, it isn't. So we need to go to our next multiple of 20, which is 60. Is 60 a multiple of 12? Yes, it is, because 12 fits into 60 5 times. 5 times 12 is 60, which means 60 is a multiple of 12. Therefore, the LCM of 12 and 20, or the lowest common multiple of 12 and 20, is 60. We are now going to have a look at square numbers. Square numbers is the result of something being squared, a number being squared. So your first 5 square numbers will be 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. So the answer to these numbers being squared will be square numbers. So 1 is a square number because 1 squared is 1 times 1, which is 1. 2 times 2, which is 2 squared, is 4. So 4 is a square number. 3 squared is 9. 4 squared is 16. And 5 squared is 25. So a common number sequence would be asking you to fill in the gaps when they are listing square numbers. So if we are not sure what those two numbers are, we need to have a look. Well, 1 we know is not a prime number and it's not a composite number, so we can't be listing those. 1 is an odd number, so we could be listing odd numbers, but 16 is not an odd number. So we need to try and remember that 1 times 1 is 1, which means 1 is a square number. So then we have a look at 16. Is 16 a square number? Yes, it is. 4 times 4 is 16. Let's have a look at 25. Is 25 a square number? Yes, it is, because 5 squared is 25. And because this is the fifth number in the sequence, we can be confident that it's probably going to be listing square numbers. Because this is the 4th number in the sequence, we can be pretty confident that it's square numbers. That would be 3 squared, that would be 2 squared, and 1 squared is 1. So that all works out. So we then just need to fill in our gaps. 2 squared is 4, 3 squared is 9. We are now going to have a look at cube numbers. So cube numbers are numbers that have been cubed. So 1 cubed, 2 cubed, 3 to the power of 3, 4 cubed, and 5 cubed. These are, the answer to all of these will be cube numbers. So 1 to the power of 3 is 1 times 1 times 1, which is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. So if we have in a number sequence a gap, 27, 64, and a gap, even if we are only given 2 numbers, we are able to number 1, 2, 3, 4, 5. We are able to number each place in the number sequence. So this would be the first number, second number, third number, fourth number, fifth number. So because we are aware that 27 is the third number in the sequence and the number 64 is the fourth number in the sequence, we need to try and play around with what we've got. So what is the relationship between 3, the number 3, and 27? We need to be familiar with our cube numbers, and we should know that we could say 27 divided by 3 is 9, or 27 divided by 9 is 3, but that's the same rule wouldn't really apply here to 64 and 4. So we need to try and remember that 3 cubed is 27, and then we apply the same rule to our fourth number. 4 cubed is 64. And then we see whether 1 times 1 times 1, 1, 2 times 2 times 2 is 8, and then our fifth number, 125 cubed. And we see that this number sequence works out well, because the gaps that were left open are filled perfectly with these cube numbers, and everything works out to be in order.